Okay, what I'm going to do next is definitely off the course. If you can do this, then again, you're going through the roof on that 9 and above. I don't think they offer a 10, but you probably go up to a 10. Um, but I want to show it you because I want you to understand a little bit about passing variables and stuff into functions. So I'm going to start off with, let me just close the shell. What I'm going to do is sort of combine statements. So here I've got 2 lines of code, and I'm just going to have 1 line of code. In fact, probably 1 line of code instead of the 3. I'm going to combine them all and explain why. So in this one, let's get our head round what's happening. We've got a library that contains a routine to get a binary string, and that's all it's going to produce is a binary string. Then we're going to reverse that string. Now, what we send in to binary string is the message that we want to display on the screen. And what comes back is num1. And num1 is used to go into the next function, which is reverse string. So really, all I need to do is, instead of using num1 there and there, I could copy that, Control C, and replace that num1 there, Control V. So I am passing in, it's getting rather long, and this is one reason probably why we need to think carefully about what we do with it. Plus we end up with lots of little parentheses at the end, and you have to be very careful. But really, I've made this line here completely unnecessary, so I can delete that. Because, let me undo that for a second, because what was returned here was a string, really we're only passing in a string, but this function itself, binary string, returns a string, so it's okay to use that, because really that will be replaced with the string, not even the variable. So let's go back and delete that line. And to be honest, I don't even need to, although it returns a string from reverse string, I don't even need to use the word answer. I could just replace this answer here, print answer, with all of this, because answer just equals all of this. So that's what answer equals, and then I'm trying to print it out. So actually I could just replace it. So let me just copy that and replace that answer with that work. Now that makes this line here completely redundant. And now my main program consists of just 1 line of code. The difficulty is that it's not very readable. Okay, it really isn't very readable at all. And the more you do this, the less readable it gets. However, it is quite good programming and quite, I wouldn't say efficient, because that depends on how you've done your code. But modern day coding relies on this kind of function calling, where instead of just calling a function with a string, you call it with a function which returns a string. It's very, very common. So there we go, we've reduced all of our main program just to 1 line of code. So if I now save that and run it, I am expecting the answer to be identical. So 1101 produces 1011. 1 line of code. And if you remember, if you just pass that 1 line of code to somebody and give them the compiled libraries, they're not going to see any of your code at all. Now that is the challenge that we set ourselves up for coding, is to make it as small and as compact as possible. However, we do lose readability, and in your project for examinations, really we're aiming for readability rather than this, and also for comments or annotations. this would be rather difficult to annotate, as it does lots of jobs just in one line. However, if we go back to how the print statement worked, or the input statements, if you remember, we dealt with input and we saw something like raw underscore input. Oops. And we had an open and close parenthesis. Now you should be able to understand that raw input is actually a function and that we can pass it some arguments. So we could pass it just any sort of string, and that would print it out on the screen. Doesn't need to be in green as a string literal. It could be a variable, as long as it sort of made sense. So we've learned now that raw input is a function, and it's working along these lines where we're sending different functions in to do different things. So that ends this one, task 6. We've managed task 6. We've managed to reverse a string. We've created a function and returned that reverse. We didn't really care whether it was just a binary number or anything, so we made a general purpose function that we could use in other programs. So we put that into a library. Didn't need to. If we don't put it into a library, then every time we need to use reverse, we'd have to write that code again. We used the loop to go over the function, and we determined which kind of loop it was because we knew that the string had a finite length, so we knew that we were going to do each and every character in that string, so it was better using a for loop than it was a while. Don't think we'd gain any efficiency using a while loop. We would just add more code. And we had to set a new string to be the empty string to start off with. The empty string, you will find, will be a very useful thing to use in your programs throughout. And then we built that empty string up by taking the character from our original string and adding it to the new string. And then once we'd done the entire thing, we returned the new string back to the caller, which was here, and then we printed that out to the screen. So hopefully you're beginning to understand or see that it's a little bit more complicated and lots of things to think about. Again, remember, I'm not expecting you to come up with this straight away. It's something to aim for. If you don't know it exists, you'll never get there. So I'm showing you that it exists.